Welcome back. Today we will be talking about law of sines. Law of sines is applicable when the triangles are oblique. That means there are no right triangles. As you know from geometry, angles are labeled with uppercase and the sides are always labeled with lowercase letters. So as you can see in this triangle, angles are labeled with the uppercase A, B, and C, and the lowercase is used to represent these sides. There are some requirements for solving the oblique triangles. So one of the major requirement is at least one side length should be given. And if one side length is given, then either of these following should be there. Either two sides, two angles, or one angle and one side. So if you remember the concepts of geometry, the same concepts will be applied here. So basically, we are looking for four basic conditions or four basic cases to solve the oblique triangles. AAS, angle angle side or angle side angle. Second is side side angle. Then the third is side side side, and the fourth is side angle side. So the first two cases can be solved by using law of sines, and third and fourth using law of cosines. We will talk about law of cosines in the next video. So law of sines, we say a side A divided by sine A, side B divided by sine B, and side C divided by sine C, and its reciprocal is also valid. So when we have to find the sides, we use the first way of writing the law of sines. When we have to find the angles, we use the reciprocal form. Now, can I prove it? Yes, we can prove it by using the basic SOHCAHTOA. So we know sine is nothing but the opposite over hypotenuse. So if we consider the highlighted triangle, we know sine A is height over B, that means h over B as per the notations. From that I can say height is, or h is equal to B sine A. Similarly, if I say sine B, that means the triangle that is shaded with pink, I can get another equation, h is equal to A sine B. From equation 1 and 2, I can put these two equations equal to each other. B sine A is equal to B A sine B. And if you just manipulate these, you will get A divided by sine A, which is equal to B divided by sine B. If I apply the same approach, we will also get C divided by sine C. So let's quickly try this. So sine C will be h over A. H is A sine C, and I can put A sine C equal to C sine A, and that will give me the another side of the equation. Combining these two properties by using transitive property of equality. Yes, we are bringing geometry again, because both of them are equal to A over sine A. So I can put all the three equal to each other, and that will give you law of sine. Side A divided by sine angle A, B divided by sine B, and C sine C. Let's try a few examples. So case 1, as I said, case 1 and 2, they can be solved with law of sines. With case 1, we have two options, angle angle side or angle side angle. So let's take angle angle side first. So we have one triangle here. So let's label it. I'm sorry. So they are asking for find missing sides and any angle. So finding the angle will be easier because two angles are given and one side is given, right? So that satisfies the condition of angle angle side. So we need the side, so we can use the basic law of sine formula. A divided by sine A is equal to B divided by sine B. Because the two angles are given, the third angle will be 49 degrees. So A divided by sine of 49 degrees is equal to 28 divided by sine 29 degrees. Cross multiplication will give you the side length. Just put it in your calculator and you should get the answer. be careful, use the parentheses. Do not do sine 49 times 28 because that will bring the error. So side A is 43.59 feet. I can apply the same procedure to find side C. As you can see from the triangle, opposite to angle A will be side A, opposite to angle B will be side B, and opposite to angle C will be side C. So cross multiplication again. So remember, it is 28 times sine of 102 divided by sine 29. That will give you 56.49 feet. So this way, we solved the missing angle and the two missing sides. Let's take the second type of case for angle side angle. So we are talking about case one only, but in two different parts, two different scenarios. So as you can see in the diagram, angle A is given as 43 degrees and angle B. Angle B, the one part is 90 degree and the another part, because it is tilted, it is 8. So total angle B will be 90 plus 8, 98 degrees. That is the tricky point. If you just take 90 degrees, then it is not the oblique triangle. Remember, the oblique triangle implies no right angle. So that will give me angle C as 39 degrees because two angles are given. I can find the third angle. And side C is also given 22 feet. So we need all the sides. So we are using the basic formula for law of sine. And all the information is there. Let's put all the information. 22 sine 43 degrees divided by sine of 39 degrees. In the calculator, you will get 23.84 feet. And that is the only information they were asking for. So for the first scenario, I have two cases. Now, let's talk about the second case, side-side angle. Side-side angle case is also called the ambiguous case because there are different ways, different scenarios you will get, different type of triangles. Either you will get, you will be able to form only one triangle, or two triangles, or no triangle. It depends upon the altitude and the side length. So if the altitude is equal to the side length, then you are getting one triangle, right? If altitude is, if one side length is greater than or equal to B, then also one triangle. So let's take one example. Angle A is given 31 degrees, side A and side B are given. So this chart is very, very important. In this chart, I already highlighted that height, that means the altitude we are talking about, is B sine A using SOHCAHTOA. So let's, we have this triangle, I labeled everything, and they want a single solution of side-side angle. So two sides and one angle. Angle A, since angle A is acute, right? So we can meet all of these criterias. So let's proceed with this. Sine A over A is equal to sine B over B because my intention is to find the angle first. That is why we are using the reciprocal of law of sine. So if I put all the information in, I will get sine B is equal to 5 times sine 31 degrees over 12. But remember, I need to find angle B, so I need to take arc sine. So arc sine of the whole entire thing, that will give you approximately 12.39 degrees. So angle B is 12.39 degrees. So we have two angles. Can we find the third missing angle? What is the sum total of a triangle? The sum total of a triangle is 180 degrees. So all the information in, angle C will be equal to 136.61 degrees. Now I need to find the missing side length, which is side C. So we are using the basic law of sine. So whenever you have to find this side length, the numerators should represent the sides. Whenever you have to find the angle, the numerator should represent the angle. So the side length will be 16.01 feet. So this way we can solve the whole entire oblique triangle. Now let's take another case where it says no solution case, where I cannot form any triangle. So let's see. So they said show that there is no triangle for which A is equal to 4, B is equal to 14, and angle A is 60. If I try to construct it, so angle A is 60 degrees and the side opposite to angle A will be side A, and that is 4. So side B is 14. So I can see just by the eyeball that I cannot create a triangle out of it because A is less than H. If I use angle, the reciprocal to find the angles, we are getting sine B is equal to B sine 60 degrees over 4. And because B is 14, that will give you more than 1. Let me put it in the calculator. So if you put this in the calculator, you will get 3.0311, and which is greater than 1. And that contradicts the condition of sine. Sine B should be, sine should be less than or equal to 1. Remember, the range of sine is -1 and 1. So therefore, we can conclude that no triangle can be formed using these dimensions. Let's take another case, another scenario, when they are asking for two solution cases using the same ambiguous side-side angle. So if they ask for two solutions, they will specify in the question that you need to find two solutions. So find two triangles. So they will specify find the two triangles for which A is equal to side length A is equal to 4.5 feet, B is equal to 5 feet, and angle A is equal to 58 degrees. So sine B over B is equal to sine A over A, because I need to find the angle first, right? So whenever you need to find the angle, put the angles in the numerator. If you need to find the side, put the side in the numerator. So that, remember to take arc sine. That will give you 70.437 degrees. Now angle B is 70.437 degrees, which is greater than angle A, right? But less than 180 degrees. So one angle will be 70.437, and if I subtract from 180, I will get another angle, possible angle will be 109.56 degrees. So based on angle B1 and angle B2, I can calculate what could be angle C. Angle C, when we are talking about B1, will be 51.563 degrees. If we are taking B2 into consideration, then angle C will be 12.44 degrees. Now to find the side C, we are putting the side length in the top. The side length A is 4.5, cross multiply. So side C will be approximately 1.143 feet. So whenever they ask for two triangles, you need to keep in mind these conditions. The another thing, you need to also consider that the largest angle, the opposite to the largest angle will be the largest side, right? Now the another thing in this is called area of an oblique triangle. To find the area of the oblique triangle, What is the area of a triangle? Area of a triangle is 1/2 base times height, right? So keeping that and the basic formula in hand, we can say each triangle has a height of b sine a using SOHCAHTOA, right? If we are considering the left side, the shaded part of the triangle only. So sine a is h over b. That will give you the height as b sine a. So I know that area is 1/2 base times height. Let's plug all the values in. Side base in this case is c and height is b sine a. So we are just replacing base and height. If I open the brackets up, I will get 1/2 bc sine a. That is nothing but the area. I can rewrite another way, 1/2 ca sine b. So what is happening? The area is two side lengths and the angle sandwiched in between. So the side lengths are b and c, and the angle between is a. Or the side length is c and a, angle in between is b. Or side length is a and b, and the angle in between is angle c. Because logically, sine 90 degrees is equal to 1, that is why we always say 1/2 base times height, because sine 90 will give you just 1. So, and remember, we are talking about the oblique triangle in this case. Let's take one example for finding the area. Find the area of a triangular lot having two sides of lengths 24 inch and 18 inches and an included angle of 80 degree. Now, so how to solve it? Let's create a rough triangle. So we have 80 degrees, 24 and 18. So given angle is included between the two sides, right? So area will be 1/2 the two sides and the angle included in between those two sides. So sine of that angle. So area will be 1/2 times 24 times 18 times sine of 80 degrees. Just put them in the calculator. So 212.7 inches squared. Let's take one application problem. So in this problem, if you can see, it is a bearing problem that we did earlier as well. So if you look at the diagram, if I use the principles of geometry, so AC is the side length and the opposite to that is DB, that is parallel. So using the alternate interior angle theorem, angle C is nothing but 58 degrees, right? So again, we are saying side length AC is parallel to side length DB. So angle C is 58 degrees, angle A is given as 28 degrees, so angle B will be equal to 94 degrees. Now, I want to know the side lengths because they want to find the total distance. So we are using the basic law of sine. So we can use the ratio in two ways, one to get side C and the another to get side A. So C will be 680.09 and A will be 376.49 using the same principles what we have discussed in the video so far. To get the total distance, add all the side lengths A, B, and C. That will give you a lovely answer as 1856.58 centimeters.